All right, it is lab day today. We're doing plate tectonic Oobleck lab. Let me zoom in real quick. So in this lab, we're gonna model plate tectonics. It would be really cool if we could just dive into the crust, cut through, see the mantle, see plate tectonics happening, but we can't. So instead, we're gonna model it. We're gonna model it with some ingredients that you may have at home, so you can probably do this at home. You can follow along with me. The mantle, which is the layer below the crust, which is made of magma, is going to be Oobleck. I don't know if you've made Oobleck before, but all you need is cornstarch and water. So about a half a cup of cornstarch, 1 cup of water. You might have to mess with those measurements a little bit to get it right, but I'll show you a close-up. I'll show you a close-up. It's not liquid, it's not solid, it's kind of in between. That represents our mantle. Our ocean crust is going to be 2 apple slices. Ignore how dirty my hands are, it's the Oobleck. But you need 2 apple slices, and you will need 4 little pieces of graham cracker for our Continental crust, which means you just need 1 graham cracker broken up into 4 pieces. Your lab handout looks like this. It has 3 different columns on it. The first column is arrows. So are the 2 plates going together? Are they spreading apart? The second column, you're doing all on your own. I'll do the first one with you. What did you observe? So I'll say things, but really you're gonna watch the video and see what did you observe. And the third column, what is it called in the real world? We'll do that one together once I'm done with the lab. Let me show you how to make an arrow. So let's zoom in so y'all can see better. If you want to type an arrow, you put a dash, and then a greater than sign and press space. It turns into an arrow. To go the other way, I put a less than, dash, space, it turns into an arrow. So that's how you type an arrow. If I was you and you were going to do this with me, I would suggest that you pause the video right now, get all your ingredients. So cornstarch, water, make your Oobleck. All you do is mix them together and stir it up. I'll give you a close-up real quick of what it looks like. And then come back to the video and keep watching so you can do the lab with me. If you do the lab, take a picture or video or something, send it to me, email or message, and I will give you a bunch of extra credit. Let me give you an up close. So this is what the Oobleck looks like up close. Mine's kind of gross because it has had graham crackers in it. And mine is pink because it's supposed to be red. It's supposed to be magma. It's really cool because it looks liquid, but it feels, I don't know if y'all can kind of see it pulling. It feels solid, so it's pretty fun to play with. Y'all will enjoy it if you make it. And that's just from cornstarch and water. Half a cup of cornstarch, 1 cup of water. You might have to adjust the measurements a little. I did. And all right. So let's do our lab. So on the screen, you can see what's happening on my little tray. And I'm gonna follow directly what the lab handout says. So the first thing it says is take 2 apple slices, place them on the Oobleck and gently push them together. Yes, this is gonna get your hands kind of dirty. It washes right off. You can wear gloves if you like, but it washes right off. It's not a big deal. It just looks so cute. Anyways, my 2 apple slices are my 2 oceanic crusts. So ocean crust, and I'm going to slide them together, so collide. Can y'all see? Yes, y'all can see. All right, so I'm putting them in the Oobleck, in my magma. I'm sliding them together, and naturally one just goes under the other. You can notice that it's probably kind of hard for y'all to see, but you can kind of see a gap right here. So I pushed them together and one went under the other. That's called subducting, like a submarine, it goes down. So let me show you again. stuck in my magma. All right, my two plates are moving on my magma. They collide, they run into each other. One just naturally goes under the other. When two plates collide, they come together. That's called convergent. If you say two cars converged, that means they crashed. So at a convergent plate boundary, the two plates collide. If they're two oceanic plates, one goes under the other. So what did you observe? You observed one plate go under the other. What is this called in the real world? So this is pretty cool to me. When one plate goes under, it's now in the mantle, this little part right here. So it's gonna melt. It's gonna be extra magma. It's gonna be like a buildup of pressure. And it has to be released through a volcano. So this is how we get volcanic islands, which are some of the coolest places in the world to me. By them colliding, converging, one goes down, it comes up as a volcano. All right, number 2, I'm going to put my 2 pieces of apple slice in the magma, and I'm going to gently pull them apart. I want you to watch in the middle, watch what happens. So my 2 apple slices, they're gonna start side by side, and I'm going to pull them apart. You can even kind of see it in the swirls. So I'm gonna show you again. When I pull them apart, watch how magma comes in from both sides and fills that space. Mix it up, mix it up. All right. Side by side, pull apart, and magma fills it. You wanna do this one kind of quick. One last time. Mix my oobleck up. All right. 2 ocean plates, they're side by side. They spread apart, and you can see it fills. So in the ocean, if you have 2 plates spread apart, this pink is, remember, it's the mantle, so it's magma. So magma is coming up. What happens when magma hits the ocean, when it hits water? It hardens, it turns to rock. So our plates spread apart, magma comes up, they spread apart like really, really slow. So I'm being dramatic. But they spread apart, magma comes up, it hardens, and it forms ridges. It doesn't harden smooth. I'm sure you'll seen pictures of magma. If not, you'll see more tomorrow in your notes. But it doesn't harden smoothly. You have ridges. So this is how you get like mountains in the ocean. And this is how Harry Hess proved Alfred Wagner's theory of continental drift. He proved it by measuring the age of the crust in the center. Where they pull apart, it was new because that magma had just risen, whereas the crust on the sides was old because that magma had been there, it's been pulled apart. All right, so next one. This one I can only do one time because the graham crackers get gross really quick. But I'm gonna take 2 graham crackers and I'm going to push them together so they're converging. Let me pause for a second. When the 2 plates pulled apart, that was diverging or spreading apart. They diverged, they separated. Once again, we have 2 land plates this time, continental. They are converging this time, they're coming together. So what do you think happens when 2 land plates converge? They just smash into each other and crumble to pieces? Let's see. Remember, my graham cracker is gonna get really gross really quick. So I'm gonna only do this probably once. All right, so my 2 plates are in here and you'll see, yeah. All right, they're colliding and they're just going up. Huh. All right, let's see if I can get it one more time. Colliding and they go up. All right, get all gross in here. So if we had 2 land plates, they collided, one didn't go under the other like with the oceanic. They both uplifted, they both went up. What do you think that's making on land? 2 plates collide, they both go up. It's making mountains. So what did you observe? You observed 2 plates go up or uplift. What does that make in the real world? It makes mountains. So that's pretty cool. That's how mountains are made. Mount Everest, the tallest mountain in the world, was made that way. Next one, take 2 graham crackers and gently push them together. I did that one. Take 1 graham cracker, 1 apple slice, and place it on the oobleck and push them together. So 1 oceanic, 1 continental, 1 of each, and I'm going to push them together. So they're going to collide. Can't do this one too many times because the graham cracker gets gross in the oobleck. All right, so my oceanic, my continental plate are in the magma. They're moving together, they collide, and my continental plate goes on top, my oceanic plate goes underneath. So they're moving together, and the oceanic just goes underneath, the continental stays on top. Remember last time when one went underneath, we had extra magma. So we do again, it's released in the form of a volcano. So that's how we get volcanoes on land. You may have heard of Mount St. Helens, which is a volcano in the US. If not, you'll learn about it this week. It has erupted, it's caused damage in the US before, and that's how it's formed. It's at a plate boundary where the ocean subducts underneath the continental crust. So you get extra magma, it comes up in the form of a volcano. Last one. Oh, okay. This one, I actually need 1 more graham cracker because mine are mushy. All right, so this one, I'm gonna come close first. It's good if you do this one not in the oobleck first. It's gonna be 2, let's do this side, 2 continental plates, and they're going to slide past each other. I don't know if y'all can hear that, but it doesn't want to happen easily. Ugh, it's like I have to push them. So, get my apple out of here, my oceanic crust out of here, and I'm going to put my 2 continental plates into the magma. I'm going to slide them side by side. I want you to think about what happens when they slide side by side 2 land plates, and it doesn't happen easily. You can hear the friction, the pressure. In the magma, it's gonna be a little bit smoother, but I'm just sliding them side by side. You can't really hear it, but it's like hard to do. It's kind of rough. Feels really cool. Y'all should make oobleck at home. Oobleck feels too cool. So, all right, when you have 2 continental plates that are side by side, so they're not running into each other, they're next to each other, what happens is they build up a lot of friction and pressure. Eventually that's released and they're able to slide past each other. This happens a lot in places like California. Some of y'all know a little bit about California. What do they have a lot of? Released. They have a lot of earthquakes. That's why sometimes you hear people say, well, there is a plate boundary that cuts through California. Sometimes you hear people say that part of California is going to fall into the ocean. That is because there's a plate boundary and they're sliding past each other. That results in a lot of earthquakes. You may have seen the movie San Andreas Fault. The fault is after an earthquake. There's a crack in the crust in between the 2 plates that makes a fault line. This boundary is unique because they're not colliding together, they're not spreading apart. They're going past each other. So, let's go back to our worksheet. Let me make sure we're recording. Okay. Remember, this middle column you are doing on your own with what you observed. So we are going to put our arrows going towards each other. I'm going to put O on top just to remind you that it was oceanic crust that went together. And really my arrows, if I could draw them, would look like this because one went under the other. In the real world, this movement colliding is called convergent. In the real world, what does this make? Remember that extra magma comes up, it makes volcanic islands. Ew. handwriting looks terrible there, but Convergent Volcanic Islands. The next one they pulled apart, and these are also oceanic, so I put OO just so you remember right now. Those are oceanic plates pulling apart. You should have seen magma fill the middle. Pulling apart is called divergent. You're spreading apart. You're getting further away. You're dividing. Oops, divergent. What is this form? It pulls apart. Magma rises, it hardens and forms ridges in the ocean. So what would this really look like? It would look like pulls apart, magma comes up, and it forms little ridges that get taller and taller, and that's how you get like mountains in the ocean. All right, next one, graham crackers collided. So these are continental. I'm gonna put C. These are continental. Really remember it looked like this. They uplifted, so they converged and uplifted. So I'm going to put convergent. It would make mountains. It would make mountains. 1 graham cracker, so continental, 1 apple slice, oceanic, they collided. So if we're colliding, what is that? It's convergent. Remember, one went under the other. So it would look like this. One goes under the other. That's extra magma right there. So it's going to come back up in the form of a volcano. So this is how we get actual volcanoes. And the last one, the 2 graham crackers, were going up and down. So you can just type in up and down if you don't know how to make those arrows, but they're going like this, sliding side by side. This can happen in the ocean or on land. There are earthquakes in the ocean as well. So this results in earthquakes. Okay, don't forget to answer your fill this in. Answer your 4 reflection questions and submit this assignment. It is a grade. If you did this lab at home, please send me a picture or a video. I will give you a bunch of extra credit because that's awesome. And enjoy your Oobleck. It's pretty cool, it's pretty fun. Wash your hands afterwards, mine look gross and crusty. Let me give you all a close up real quick of this worksheet. Here's a close up of what I typed. You could pause it here, or what I wrote. You could pause it here if you need. I'm sorry, my handwriting is not the best on here. Here's those cool little drawings. You don't have to have these. They're just good for you to see. I cannot wait for y'all to learn more about this for the next 2 days.